I'm going to discuss singleton design pattern in C Sharp. Okay, now let's read this particular sentence. The main purpose of the singleton design pattern is to prevent creating more than one object from a given class. That means if we have a particular class, we want to prevent creating more than one object from that class. Okay, so in order to explain singleton design pattern, I use a C# code. Now let's look at it. Now here we have a class called manager, and there I have included a constructor. Okay, so now execution begins. Inside the main method. Now this is the very first line of code that gets executed. So an object from manager class is created. An object from manager class is created, and then its memory location is stored in m1 variable. Okay, so now after that, then this particular line of code is executed. Okay, then another object from manager class is created, and its memory location is stored in m2 variable. Okay, now you can see two different objects have been created. So if you check this condition, if actually I should be simple here. Okay, so if m1 equals m2, we check the condition. Actually here these are two memory locations, therefore definitely m1 not equal to m1 not equal to m2 in this situation. Therefore the condition is false, and this one, two objects, this line of code will be executed. Okay, and therefore the output of the above code gives two objects. The code after applying the singleton design pattern is given below. Now in this situation, when we attempt to create objects, okay, in this situation when we try to create objects, more than one object can be created. Now if we apply singleton design pattern, we can restrict, we can prevent creating more than one object from a given class. So in order to do that, we have to do certain modifications to the class. Now what are the modifications that should be done to our manager class? First thing, you have to make the manager class as a sealed class. Sealed. The sealed is a keyword. Okay, sealed is a keyword. If you use this particular keyword for a class, actually we cannot inherit from that class. Okay, now we cannot inherit. We cannot create child classes from this class. Actually, that is the first thing we do. The reason is, if we allow inheritance, then one may inherit from this class. Okay, inherit from this class, and from the inherited class we can create any number of objects. Therefore, first we prevent the ability of inheriting the class. Okay, that is the first thing we do. Then the second modification, now you can see here the first modification. We have used the sealed keyword, and the second modification is, now earlier our constructor was public, now we convert it to a private constructor. Now constructor is private, therefore constructor is accessible only within the manager class. Outside the class, constructor is not accessible. That is why we have made it private. So no one can access the constructor from outside the manager class. Okay, now the other modification, we need to include a static. A static read-only manager M. Static read-only manager M. Okay, so here we create a field. Name of the field is M. It is a class field, a class variable. Since we have used a static keyword, that means this is common to all the objects we create from the manager class. Read only, this is a keyword. Okay, read only keyword means if you use read only keyword for a variable, okay, then we can assign a value to that variable at most once. Okay, if we use read only keyword to a particular variable, we can assign a value to that variable at most once. Okay, that is the idea of a read only keyword. That means if you declare read only int x, okay, read only int x, understood? Now if we try to this is possible. Now we have assigned a value. If we try to assign a value again, this will give us an error. Okay, or else if you do something like this, now we have already assigned a value to x variable. If we try to assign some other value, then this will give us an error. That is the idea of read only keyword. To this m variable, to this m variable, then we create an object from manager class. In this way, then memory location of the object we create from manager class is stored in reference variable m. The type of the reference variable is manager. Okay, that is the other line of code we have to include within the class. Then after that, we have to include a static, that means a static constructor, class type constructor. No, sorry, extremely sorry. We have to include not a constructor, a property. We have to include a property, a class property. Here we have used a static keyword, and our property we have made it as public because we have to access. We need to access from outside. Okay, therefore we have made it as public. Static manager m. Return type of this property is manager. Okay, return type of this property is manager. Then this is a read only property. This is a class property, and also this is a read only property. Okay, read only property. Now here we return the value of the reference variable m. Now let's see. Now we have done these modifications to our manager class. Now see what happens when we execute this. Okay, then when we execute, before that I will erase these highlighted parts. Then then we execute this particular line of code. Manager m1 manager dot m. We access the property. We try to access the read only property. There what happens? It tries to return the value of m. Okay, so value of m. Now m is a class field. M is a class field, therefore it is common to all the objects. M is there. We have not yet created objects, but still m is there. If for the time being, let's say we create set of objects, then for all those objects m is common. Now we try to return the value of m. Then when we try to do that, here this is the value. Then an object from manager class is created. An object from manager class is created. Okay, an object from manager class is created, and memory location is stored in m, and now we return it. So here m1, now m1 it is assigned to m1. Now m1 stores the memory location of this particular object. Okay, then now we have created one object. Now if our design pattern, Singleton design pattern is successful, we should not be able to create more than one object. Then let's see what happens. Okay, then now here when we execute the second line of code, it tries to access manager.m. Manager.m. Now our variable m. Okay, earlier actually variable m was storing the memory location of this object. Okay, in earlier situation when we try to execute this line of code. Okay, then again we try to access manager.m, then it tries to return the value of m. Okay, then when it tries to return the value of m, again this one is invoked. Again this one is invoked. However, since this is read only, variable, we cannot assign a value again. Okay, we cannot assign a value again, therefore new object will be created, but its memory location cannot be stored in m, okay. New one will be created, okay, but when we try to store the its memory location in m is read only. This is not allowed. Therefore, the memory location of this object cannot be stored in a reference variable. Then what happens? It will be deleted. That is called the garbage collector. This object will be deleted. Okay, then when we try to return the value of m, actually memory location of this particular object is returned, the same object. Therefore, m2 will also store the memory location of this object. Now, if we check this particular condition, now m1 and m2, they both of them store the memory location of this object, therefore they are equal, and therefore this line of code will be executed, and the output of the above code gives one object. That means now after we have done the modifications to the manager class, now we cannot create more than one object from the manager class. Okay, that is the Singleton design pattern. This is widely used, and I am not going to explain the applications of the Singleton design pattern. I just wanted to explain the basic idea of the design pattern as simple as possible. Okay, and then hope you understood well. Okay, and thank you for watching the video.